Alright guys, welcome back, and today we are going to be looking at reflections of parent graphs. And so for the thing slash warm up, I have what does the graph f of x equals negative x squared look like in comparison to f of x equals x squared? Well, we should maybe be comfortable with seeing these already. And what we are going to do is let's just graph x squared first. We know x squared is this nice U shape, so that's f of x equals x squared, right? And now negative x squared, we've seen this come up in some of our problems, right? Well, if I call that f of x, I should actually call that f of x, right? So f of x instead of y. Negative x squared is just going to be the same thing, except we've turned it downwards, right? And I know my graphs don't look entirely the same, but they're supposed to be the same, except this one is just flipped down, and that kind of makes sense, right? Take whatever x value we had here and make it negative. So it makes sense that all these are going to be negative going down like here. And we're going to get to these reflections. So like with translations, we can either have a negative inside, or I should say outside the function first, outside the function or inside the function. And when I say inside, I mean kind of like with the x. Let's take a look at the function f of x equals the square root of x. And so we're going to go to Desmos first for this. And when I have to do the square root of x, right? So square roots of x, it's just this looking function. And now when I say outside, I mean outside that square root, right? So let's see what happens when we put a negative there. Well, kind of the same thing that happened when we put a negative in front of the x squared, right? We flipped everything down. We said, take whatever value we got and make it negative. And that's exactly what we did, right? Without that negative, we're up here at 4, 2. And then as soon as I put that negative in there, we plugged in 4 and we got out 2. But now we just said, well, take whatever you got and make it negative, right? So it makes sense that now 4 is going to be at negative 2 along with every other point this way. Now let's see what happens. And notice that is a reflection across the x-axis, because this is the x-axis, right? We've taken this and we've mirrored it over this x-axis. Now let's put it inside that square root with the x. Now we'll notice that we've taken this function and we flipped it over the y-axis this time. This time we've reflected it over the y-axis. And this one might be harder to think about at first, but I think once you work with it a little more, it kind of makes sense, and especially in this function, right? So we said, what we basically said is whatever you plug in for x, now you're plugging negative x in and getting out the same value, right? So, for example, before we put that negative in there, we were at 4, 2, right? The square root of 4 is 2. But now, when we put negative x in there, if we put positive 4 in here, then we're going to end up having the square root of negative 4, which we can't graph on real axes, right? That's an imaginary number. So we can't graph that over here. But what we did say is we said take 4, make it, so now we'd have to get a value, we'd have to plug in negative 4. And when we plug in negative 4, normally there wouldn't be anything here. But now it's saying make the opposite of that. So that would be positive 4, right? Really, when we plug it in here. So negative 4 actually makes a positive 4, which turns it there. And I know it's kind of weird to think about it like that, but you could also just know that when it's with the x, you reflect over the y-axis, essentially because you've traded all the values on the right side to the left side. That's what you've said. You said take every positive x and make it a negative x, right? And so here are the negative x's, right? We're not talking flipping on the y's. We're not talking making the value negative. We're talking making our x's negative. And so when we come back to this, we again have two options. We have outside, and let's do the first one there that we talked about. So the first one we talked about for outside was the square root of x, and that's what it means to be outside. Or before I do that, I should actually probably write. So remember that the outside was a reflection over, and this one was the x-axis. It flipped downward, right? Because we said take whatever value you get and just make it negative. So on a graph, right? If we had this, we said take whatever value you had and make it negative. So really, we're taking this, we're flopping it down here, and we're making it negative. So we've really reflected across the x-axis. Now inside with the x, we had a reflection over the y-axis. And because when we have f of negative x inside, we're saying take whatever values you had for positive x and make it negative x, right? And so that would be a reflection over the y-axis. And so for our example of the square root, the negative on the outside would be like that, and on the inside with the x would be in there like that. And now, now we could think about the rest of our functions, right? Outside the x squared, inside the x squared doesn't really matter because negative x squared is going to be a positive x squared, but that's what it would look like, right? And we have negative x cubed or negative x cubed if it's together with the x, right? What else? We have the cube root, the negative cube root of x, or the cube root of negative x if it's on the inside, right? And what else do we have? We had absolute value, right? So a negative on the absolute value would be on the outside, and a negative on the inside. Again, really wouldn't matter because it just says take whatever this is and make it positive. And once we think about it, right, for these two where it doesn't matter, the x squared and the absolute value of x, really what this means is a reflection over the y-axis, right? So when we do this, think of the absolute value, right? We do reflect it over the y-axis. It just ends up being the same thing, right? So I think I might be missing one here, and that is our exponential. So on the outside would be negative 2 to the x, and on the inside with the x, the negative would be with the x up there. Now, let's just go through some delta math examples to make sure we know what we are doing. So we're starting with our square root function that we started with, and this is inside, right? This negative is inside, so we're not translating yet. We're not moving this green anywhere. We're not moving the whole function anywhere. We're just saying take all these positive values of x and make them negative values of x, right? So that one should be good, and it is. Same thing here, right? The negative's on the inside, so we're not flipping over the y, but we're saying we're not flipping over the x, we're flipping over the y because we're saying whatever positive values of x we had, let's make them negative, and whatever negative values we had, let's make them positive. Again, this one is inside negative x squared. We would really reflect it over the y-axis, but when we do that, we just get itself. So that one actually doesn't change, right? And that makes sense because in parentheses, negative x squared is positive x squared. So nothing really changes there. Let me get a good one. And now this is where it changes. We have the negative on the outside, so that says take whatever values you have and make them negative, or if they were negative, make them positive, right? So since it's on the outside, we're flipping across the x-axis. Now let's do a couple of the level 2s where we got multiple things going on possibly. Okay, so now we have an exponential, right? And this negative is on the outside. When it's on the outside, you're saying take whatever was positive and make it negative. And notice here, since I was at 1, 2, I want to match 1, negative 2, because I wanted to make that positive 2 negative. Not going to worry about that one. Let's do this one. So these ones are a little weird, right? Because now we have both. We have, so a negative on the outside, right? That negative's on the outside. On the outside means take whatever values you have, make them the opposite, right? Or if it's on the outside, reflect over the x-axis. And then if it's on the inside, also reflect over the y-axis, right? So we have 2 to do there. Similarly, skip on to a new one. So with this one, again, outside means reflect over the x-axis, and then inside the negative means reflect over the y-axis. So now we are going that way. And then real quick, let's put all the stuff together that we have learned, right? So we've learned one like this, 2 to the x plus 1. All that means is we're shifting it up 1 if we remember. So this is kind of putting together our review with what we know. Now let's get some other things involved. Okay, so now the first thing I'm gonna do, I'm just gonna ignore this 2 for a little bit. You could do it in any order, but I think it's easier to do this first. So negative on the inside means switch it with the y-axis, right? Reflect over the y-axis if we are on the inside, and then after that we need to add 2 to it. And that's combining what we know. Okay, so now there's some more stuff going on here, right? So we have a cube root. Negative is on the outside of the cube root. If the negative is on the outside, that means take your positives and make them negative, or take your negatives and make them positive, or if it's on the outside, you can just remember flip over the x-axis. Minus 1 on the inside means move to the right 1 because it's opposite day inside, and then negative 3 on the outside means move down 3. So we had 3 things going on there, right? And maybe we can get one more of those going on. So first off, negative on the outside means reflect over the x-axis. Plus 3 on the inside means move left 3 because it's opposite day. And plus 1 on the outside means move up 1. And that should help you guys be pretty set for the Delta Math problems. We'll go through one more just in case. So negative on the outside, again, means reflect over the x-axis. And then subtract 1 is moving down. Not too bad once you get the hang of it.